All right, guys, in this video, we're going to go over reflecting the graphs about the X and the Y axis. Okay, in the previous videos, we went over vertical and horizontal shifts and combining those. All right, so if we take our basic functions, whatever they may be, the quadratic, the cubic, the absolute value, etc., if we take the basic function and we put a negative sign in front of that, so we're taking, like, it's basically the opposite of f of x, okay? What that does to the graph is it reflects it about the x-axis, okay? Now, if we graph y equals f of negative x, it's kind of like, we're replacing x with negative x, okay? We're going to reflect that basic graph of the function about the y-axis, okay? So you can kind of think about some of the symmetry that we talked about earlier. You can think about some of the reflections that you did in geometry class. Okay, so when we're transforming these graphs, when you see a negative f of x, okay, we're reflecting in the x-axis. When you see f of negative x, we're reflecting in the y-axis, okay? Now, this first function, you can see it's our basic function would be f of x equals x squared, okay? And what we're doing is we're putting a negative sign in front of that x squared, okay? So what's going to happen here, we're going to reflect that in the x-axis, okay? So you can see our basic quadratic function here in red, and just as soon as we put that negative sign in front of the x squared, we're reflecting every point on this parabola here in the x-axis. So you see it's kind of like it folds down using the x-axis as its fold, okay? So this blue graph is the graph of f of x equals negative x squared, okay? Now, notice if I were to replace x with negative x, okay, if I had a negative x in parentheses here, it's going to reflect about the y-axis. Well, this basic parabola, if it reflects about the y-axis, it's still the exact same graph that we started with. So there's really no reason to go over that here, but I did want to talk about it. But the graph would be exactly the same as the basic quadratic function, okay? In the second one here, we've got our square root function, okay? So in the first part here, we're replacing x with negative x, okay? So that's going to be where we're reflecting about the y-axis. And the second function here is where we're preceding our basic radical function with a negative sign. So this one would be a reflection about the x-axis, okay? So let's go ahead and put those graphs up, okay? So again, our basic square root function is this red one here, okay? So f of x equals the square root of negative x. That's a reflection in the y-axis, okay? So that's going to be the blue graph here, okay? So f of x equals the square root of negative x. We're taking this red graph and we're reflecting it over here using the y-axis as our mirror, for example. It's our reflection line, okay? F of x equals negative square root of x. Again, that's going to be a reflection in the x-axis. Okay, so that's going to be this green graph here. So you can see the difference between the two functions here compared to the basic square root function and why those reflections occur the way they do. Okay, now in the next problem, we're going to go ahead and do this one in this video too. Okay, so here's our function. Okay, it's not one of those basic functions, the quadratic, cubic, absolute value, radical, anything like that. Okay, this is a function. We're just given this function. It's a function because it passes the vertical line test. Okay, and I'm going to go over, we're going to do this one. We're actually going to graph this one. So let's move on over to the graph and we'll do these next two problems. Okay, so we're given this function here that you see that's already graphed here. And in our first problem, we want to graph f of negative x, okay? So we need to remember, again, that's a reflection about the y-axis, okay? And we're replacing all the x coordinates that you see here with a negative x. So I'm just going to go from right to left here. So this, instead of being 5, 0, it's going to be negative 5, 0. We're replacing x with negative x. So negative 5, 0, negative 2, 10. This stays 0, 0, because 0 doesn't have an opposite. This would be 2, 6, 5, 0, 8, negative 4, and 10, 0 for that last point, okay? So as we plot those, okay, so you see I've placed here at negative 5, 0, the reflection of 5, 0. Okay, so I'm going to reflect all the points that you see. So that's at negative 2, 10. Again, the origin reflects to itself. Negative 2, 6 becomes 2, 6. Okay, negative 5, 0 becomes 5, 0. Negative 8, negative 4 becomes 8, negative 4. And then again, negative 10, 0 becomes 10, 0. Okay, so when we connect all those points and we draw it just like we had in the original function, it should look something like that. Okay, so that's the graph of f of negative x, all right, which is a reflection in the y-axis. So if we take that same graph and we're going to graph this time negative f of x instead, we're going to have that reflection about the x-axis, okay? So in this case, all the x-intercepts are going to stay the same because when you're reflecting about the x-intercept, those values aren't going to change because what's going to change, the y-coordinates are going to be the opposite this time, okay? In the previous one, the x-coordinates were the coordinates that became the opposites, okay? So the negative 10, 0, that x-intercept there is going to stay in exactly the same place. So the next point, instead of being negative 8, negative 4, it's going to be at negative 8, positive 4. Okay. The next point is an x-intercept. It's going to stay the same. The next point, however, would be negative 2, negative 6. The origin again stays the same. Then we've got 2, negative 10. And then our last y-intercept is at 5, 0. That remains the same. Okay. So again, remember we're reflecting everything about the x-axis, so when we draw the graph, it should end up looking like this, okay? So that's a true reflection about the x-axis, okay? So this would be f of x, this would be negative f of x. Again, all the y-coordinates become their opposites, okay? So that's how you use the concept of reflections when we're transforming graphs.